Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 5, Section 4 with you a little bit, the triangle mid-segment theorem, and it's exactly that. We are going to look at the midpoint of each segment or side of a triangle, and as it says here, a mid-segment of a triangle is the segment that joins the midpoints of two sides of a triangle, and every triangle has three mid-segments which form a mid-segment triangle. So basically, if you take the midpoint of each side of the triangle, you get another triangle, and you can see here that each side here is congruent because they're hitting at the midpoint. Um, and one example here is showing is basically it's saying that in this triangle show that the mid segment KL, which is this blue segment here, is parallel to side or segment GJ, and that KL is 1/2 GJ. So two things are going on here. Basically, we're trying to show that these two, the blue line KL and the segment GJ, are first of all parallel, and then one is half the size of the other. And so what's happening in this example is we're going to be using not only the slope formula, we also want to use the distance formula as well. And that's really looking at the first couple steps here. We're finding the midpoint, and then we're taking the slope formula, which remember is the change in the y's over the change in the x's, and we're seeing that the slopes are the same, 1/2 and 1/2, and then we're going to compare the lengths by using the distance formula, and KL turns out to be 2 times the square root of 5, and GJ turns out to be 4 times the square root of 5, so exactly 1/2. And of course we want to use this use this example to kind of show this next theorem, and that is the triangle mid-segment theorem. Basically, this is telling us a mid-segment of a triangle is parallel to the side of the triangle, and its length is half the length of that side. So again, you can see here from this picture, segment DE is parallel to AC. This is true by the theorem. And side DE, right here, is exactly equal to 1/2 the length of AC. And so we can use this theorem now for some of these other examples that we can look at, where we're finding the measure of UW and the angle, measure of angle SVU, and so forth. So be sure to take a look at these examples, and if you have any questions, of course, please let me know. Thanks.